ROS developers, and welcome to this new video series which is called Solving the Project of the Week Challenge. In this case we are here to solve the Project of the Week Challenge 2. I hope you already have seen the first video so you know more or less how this works. So yeah, let's go straight to the point and let's click here in the link to get our project. As always, if you don't have an account, you will need to sign up. I already have one, so I can directly sign in. And once I log in, I will have the project copied to my workspace, as you can see here. And then I can open it directly hitting here in the Open Project button. And then I will have to wait a few moments until the whole environment, the ROS project loads. And meanwhile, we can have a look here to the notebook, a preview of the notebook. So as you can see, this one is intermediate level. The first one we solved, the challenge 1, was a beginner level. This is an intermediate level, so it will require a little bit more of ROS knowledge, but actually it's not that hard. But for instance, this one is oriented to ROS navigation. And let me talk you here about our Robotic Night Academy. So this is our online academy where you will find many practical online ROS courses using different simulated robots. Everything is on the cloud, web-based, so you can do them in any computer. For instance, I'm on a Windows computer right now. You only need a web browser, and here, for instance, you can find many courses. Here you have, for instance, the ROS navigation course. So by doing this course, you will have the necessary knowledge and many more knowledge, but in fact, if you do this course, you will find this project super easy to solve. But yeah, you can find here many courses where you can get all the knowledge that you will need in order to solve all the challenges that we publish. So each week, each Thursday, specifically, we are going to be publishing a new challenge. They are going to be either intermediate, beginner, or advanced level. And yes, you can see you can get them with a single click. And you will have to click here in order to open the project. As you can see, this one has already opened it. And now all you have to do is to follow the instructions explained here in the notebook. So the first thing to do is to open an IDE, as you can see here in the Tools IDE. So I will come here and I will open an IDE. And here you will find in the Catkin workspace all the packages for this specific challenge. Then here we have instructions to launch the simulation. In this case, we need to come here to the Simulations panel menu and choose the main.launch file from the Summit Excel Gazebo. So if I come here, choose launch file, I will have a list with many launch files. And if I look for the Summit Excel Gazebo package, which is, here we have it, Summit Excel Gazebo, and it's the main.launch file. Now I will click here in the launch button and this will start loading, starting my Gazebo simulation, yeah? The one for this project that we are going to be using in this project. Then I keep going and here I will have instructions about the problem to solve. So basically here I have some instructions which are to launch here the move base node, open RVs, and in RVs basically I will have to set up all this and send a goal to the robot, and the robot should be able to accomplish it. In this case, we are setting a goal here in a, let's open here the simulation, which has already loaded. So as you can see, we have a Summit Excel robot here in a small room here, a small building, a small office with two different rooms here. And basically what we are going to have to do is to launch our navigation system, our path planning system, the move base node, and through RBIF be able to send a goal, which is in this room, specifically in this case, inside this room, and the robot should be able to properly execute and reach that goal without problems, as you can see. Yeah? Then what happens? Well, what happens is that if I try these steps, let's do it right now, this won't work. Yeah, so let's do it right now. Let's go step by step. So the first thing is to execute this command here. Let's copy it directly here into the shell. Let's execute it. Okay, yeah, so in case you see this error, you have to source the Catkin workspace so that it detects this package. Alright, let's repeat the command. Now it will work. Now from another shell, I'm going to launch RVs with this command, run RVs. And now in order to be able to visualize RVs, as it's saying here, you need to open the graphical tools here in the tools menu. So let's do this as well, graphical tools. In my case, I'm going to open them in a different window because I like it more like this. Then, yeah, so here we will be able to load a predefined configuration, which is nice because otherwise we have to spend some time trying to configure this RVs. And here it's opening RVs, excellent. And here I can come to OpenConfig and select this one, which is in my Summit Path Planning RVs, and it's called ROS-related.rvs. So I can come here, File, OpenConfig, and I can select this configuration, which is here in Catkin Workspace SRC, Path Planning RVs, ROS-related.rvs. And this will load the configuration for this project for RVs in order to visualize everything. But as you can see here, we have some warnings, strange warnings. So this is not quite looking like this, which is how it should look. Furthermore, here we have seen some errors, which doesn't look very good. So yeah, basically what we need to do now, this is our time, we need to find the error. What's going on here? So here, we can see an error message, fatal, in fact, which says only topics that use point clouds or laser scans are currently supported. Okay, so here it's basically what it's doing here, it's to loading some plugins using plugin obstacle layer. As you can see here, subscribe it to topic Hokuyo laser. Here it says only topics that, okay, so it looks like when trying to subscribe to this topic, to this Hokuyo laser, in the plugins, in the obstacle layer, specifically, there is some type in the topic which is not correct, yeah? So it only supports point clouds or laser scans, yeah? Then, what should we do? In fact, here, if we come here to the project, we have a small hint down here which says, hey, you should have a look at this package, My Summit Path Planning. So let's do that. Because I already know about ROS navigation, I know that this configuration, the plugins configuration, is done here in the path planning, in the move base node, in the configuration files, in fact. So these plugins are usually loaded for the cost maps, yeah? So if I open, for instance, the local cost map parameters, here I will see that this obstacle layer is being loaded here. This plugin, which is called obstacle layer, you remember this one? It's this one here, using plugin obstacle layer. So as you can see, this is being loaded here, yeah? But here it is being loaded. It's not being defined here, yeah? So the error, it's not actually here. Where is being this plugin defined? Well, it's defined here in the common parameters for the cost map, yeah? So we have the parameters for the local cost map, also the ones for the global cost map. But here we have a file where we define these plugins for both the local cost map and the global cost map. So let's open this file here, and as you can see here, we have the obstacle layer definition, yes, which is called, in fact, Hokuyo laser. Yeah, this is the Hokuyo laser that you can see here, that it's trying to subscribe to. Yeah, then here it's where this obstacle layer is defined. So here we can see that this is defined, and the frame of the laser is named Hokuyo base link, and the data type it's odometry, and the topic name it's scanner. Yeah. So okay, some things to do here. First of all, if this is a laser, it's very strange that the data type is odometry, right? So the usual thing is that this is a laser type of message, not an odometry message, yeah? And the topic name, so let's look first of all for this topic name. We can come here, let's close this, we will launch it later again. And if we do a ROS topic list, and we look for this scanner, Oopsa, nothing. There is no match. Okay, so this topic does not exist, first of all. Yeah? Then, sorry, it's ROS topic list. Then we know that this scanner topic does not exist. Yes, so the laser data of this robot must be placed in another topic, must be being published in another topic. So usually, let's try to, for instance, do a grep for a scan. Usually, the topics that contain the laser data are called scan something, scanner. Let's see if we find something. We need to add grep, of course. Grep scan. Okay, so here we have a match which is called Hokuyo base scan. Okay, this looks pretty promising because this plugin is called Hokuyo laser. The frame we see it's called Hokuyo base link. And here we have Hokuyo base scan. Okay, so let's have a look at this topic. ROS topic echo. Hokuyo base scan. Let's see if there's something here. Okay, yeah, so as you can see here we are having data published. So it really looks like this is the topic we are looking for. So let's have a look with ROS topic info into this topic in order to see the type that it uses, Hokuyo base scan. And here with this ROS topic info we can know that the type that it uses is this laser scan. Okay, this makes much more sense, right? So let's copy this topic name. First of all, let's copy it and let's paste it here instead of this scanner which doesn't exist. And also let's get this type which is laser scan. Let's copy it as well and paste it here instead of odometry, which doesn't make any sense. Okay, so let's try to save this and let's try to relaunch now the move base node with the command we used it before. Let's see what happens. Here we have it. Okay, let's launch this. We already have RVs here working. Alright, so this is not working because it has not yet been started. All this launch file is still being launched. So let's wait a few moments until this is properly launched and start. And yeah, well, meanwhile you can see here as well how to claim your prize. In fact, we are going to do it also when we finish this. But yeah, basically it's super easy. You will have to save the project, get the link to share this project, and publish a tweet with this structure in Twitter. And then the first one who does this, or the first ones, will get this amazing t-shirt. Yeah? Of course, you will need to check that you can receive in your country, because there are some countries that we cannot send, but you can check this here in this website. You can check if your country can receive shippings from this website. Yeah. Okay, so this has launched and apparently there are no errors now. So this is looking quite promising. Now, if we come here to RBs, all right. So this looks much better. Yeah. This is very much more like this image we can see here, which is the expected thing, yeah? So now what we have to do is to first of all set an estimated pose, which it's, yeah, we can say it's here. And now we have to send a navigation goal, which is inside this row. So let's do this right now and let's see what happens. Okay, so it looks like the robot is heading towards the goal. So this looks pretty promising. Let's see in the simulation. Yeah, in the simulation as well, the robot is going there, as you can see here, both in RBs and in the simulation. It looks like the robot is reacting and it's going towards the goal. Here it's still improving his localization with the Monte Carlo particle algorithm with AMCL. And yeah, so here as you can see it's improving a lot his localization. And yeah, so this, I can say right now that this is working. Yeah, the robot is going towards the goal. So basically, yes, we have solved the problem. Yeah, so we have solved it. Then, what should you do now? So the next step would be to save your project by clicking here. Then you will come here in order to go to the main ROS developers ROS Development Studio screen, and then here you can get the link to your project. Once it is solved and it is saved, you will copy this link, and then you can come here and get this structure as well, and come to your Twitter and create a new tweet, paste this and substitute this project link here. You delete this and you substitute it with the link to your project, and that's it, and you tweet it. So this way we will receive it and we will be able to evaluate if you are the first one to solve it, if it is correct, etc, etc. Then you can also add any comments you want here, like, Alberto, you are really handsome, for instance, and then you will get extra points. No, that's just a joke. So actually the first one who solves it, the first tweet will receive like this, and I can check that it is correct, he will be the winner, even though he says bad things to me. I really don't care. So yes, you can see this got reached. So as you can see, this has worked. So we have definitely solved the project. And yeah, so that's all for this second video, for this second challenge. And hope you are enjoying this series. Hope you are enjoying trying to solve the different challenges we are publishing. Remember, we publish a new Project of the Week challenge each Thursday. And yeah, so see you in the next video. Goodbye.